go through the questions?
Yeah, let's do that.
Okay. So, I don't know if okay, she's still there. So, Christy, I don't have my SPSS today, and I was explaining to them before you got on that that's the reason why I wasn't able to do much of like the homework. So I understand like the terms and stuff, but when it comes to the graphs, I might not be much of a help right now.
Do you have it downloaded that yet? Like, do you just not have it today, or?
So it's on my husband's computer.
Oh, okay.
And he flew out to Michigan yesterday to do a job interview, and he took his computer with him. And the past couple of weeks, we haven't been using it, so I was like, oh, yeah, I won't need it. So, yeah.
That's really good. As long as you have it for the future, that's good.
Right, So, do you guys want to start with section 2?
Yeah.
Yes. Okay, so number 1, what are the requirements for creating a 95% confidence t-interval? And so I just found the answer in the textbook, and 1, it is a random sample. Oh, so one of the requirements is that it is a random sample from a population, and then the means are normally distributed.
Mm-hmm.
Okay. Anything else to add, anyone?
I don't think so.
No.
Okay. And then, do you want me to just keep reading? Or
Yeah.
Sure.
Okay, when the data above create a 95% confidence interval to estimate the mean age of all clients who buy an investment property, input the numbers you computed in number 7 of part 1 into the confidence interval formula. Show your work below. The t-score for a 95% confidence interval from the t-distribution with 14 degrees of freedom is 2.1448. So were you able to do these then, Rebecca?
No, so
Okay.
I couldn't do this one.
Okay, and I was waiting to do it with you guys.
Okay. You know what? I'm glad that you guys did, because I needed help with it. I found it out. I had to Google a few things, but I finally found it out. So this will be good to go through it again.
Right.
I had a hard time. So the formula that we would use was the mean minus t-score times standard deviation over square root of n.
Right?
Yeah.
Okay. So for me personally, I couldn't figure out which number went where. I mean, I know that should be pretty self-explanatory, but I don't know why I couldn't do it. So do you guys want to try to do it? And then if we have questions, we can, just because now I know how to do it. So I just want to see if you guys had as much of a problem as I do. Does that make sense?
I kind of have that same problem, Brooke.
Okay.
And so I just thought, well, maybe it's because I can't use my SPSS, and that's the reason why. Because, I mean, we did really well last time with that formula, and so I don't know exactly which numbers to put in too. Does that make sense?
Yes. Okay. Well, I'm glad that I'm not the only one then, because I was like, oh no, I'm going to show up and they're going to be miles ahead of me. So how I figured it out, and maybe, is it Kirsty?
It's Kirsty, but
Kirsty. Sorry.
No, it's all good.
I hate when my sister's Laura, and I hate when people call her Laura. So I'm like, I've got to get this right. Okay. So in number 7 of part 1, you find the sample mean and standard deviation. So did you guys do that?
Yeah.
Okay.
Okay. Yeah.
So then you take the sample mean, which was 46.73, and then you minus, so then they give you the t-score in number 2, which was 2.1448 times the standard. Oh, sorry.
For this one, no, you're fine.
Okay.
But for number 2, they're asking you to create a confidence interval, right? So for that, you want to use the confidence interval formula. And so the first thing you could do is just find the margin of error.
Okay.
So if you want to do that first, it's a little bit easier, and then you can minus it from the mean and add it to the mean.
Okay.
Okay. A little less complicated.
Yeah, that's what I was going to say. So did I just make it harder than it needed to be?
Well, I mean, either way, because this is the z-score one, but if you just replace t with z. So that's the one for the formula for the confidence interval, right?
Right.
Except it has t instead of z. But for me, it's a lot simpler if I just do margin of error first, which is this equation right there.
So,
Okay.
sorry, will you
And then
hold it up
just
again?
plus and minus it from the mean, because that makes it a lot simpler and it's not so many numbers at one time.
That helps a lot.
Okay, so I guess my question is, what do you use as the t? Is that the, hold on, for some reason my computer is like freezing.
Oh, no,
So what do you normally put in for t?
So in these ones, it gives you the t right in the question. So in number 2, it says the t-score for a 95% confidence interval from the t-distribution with 14 degrees of freedom is 2.1448. So your t is that number.
Okay, so that's what I got too, even in my long ways.
Good.
Wait, sorry. I guess I'm just confused. Where does it say the t-score?
After number 2, in that big long paragraph that starts with the data above, create a 95% confidence interval. If you keep reading down in that paragraph, it tells you what t is.
So that last sentence, the t-score for a 95% confidence interval from the t-distribution with 14 degrees of freedom is 2.1448. Can you see that, Rebecca?
Okay. Yeah, now I can see it. For a minute, I was like, am I in the wrong section?
That's what I thought too.
So that's the number. Oh, that's not bad. Okay, so 2.1148448. And then you do, so with the S, what would you put in for S? Is that the percentage?
So S is your sample standard deviation is what that stands for. And you calculated that in number 7 of part 1.
Oh.
So that's your 8.83.
Yeah. Yeah, so I did do this right, but I just did it in the way long way. Probably the longest way possible.
Which you probably got the right answer then. It confuses me to think of it all as one long equation.
Yeah.
So I like just thinking in a margin of error and then just adding, subtracting.
That's so much easier. Yeah, because that's what I said. Because I checked it after I did my assignment, I checked it and I was like, oh, I got it right, but how?
And then for what 8.83 is divided by, is that the 14 degrees of freedom?
No.
That's actually, yeah, go ahead.
That's the number of the clients that they use, so that's 15. That's your sample size.
Okay, that's right. Got it.
And then how I figured that out was, I actually Googled it. Actually, I thought it was in our textbook. But maybe what I'll do is I'll take a picture of it and email it to you guys, because there's a little table that helped me figure out what to use for the N number. So I'll send you guys the table too.
Oh, that would be awesome, Brooke.
Yes, because when you told us about the table last time that I totally missed over it for the other section, I was like, oh, that's 20 times easier when you have a table.
Yeah.
So I'll send that to you guys, and then it helped me.
You just have to remember that N is just always your sample size. So where it gives you the numbers like the 27, 49, 56, 45, you just count how many of those are, and that's your N.
Okay. I just didn't know for this if it was like something tricky, because we switched out for the T, so that's why I was wondering.
Okay.
Perfect. Okay. So then when we do M equals T times S over N, or square root of N, excuse me. So did you guys compute it then? Do you guys have your...
Let me do it. I'll do it right now. Hold on.
Okay.
Okay.
So what did you get then for the answer?
I got 4.889.
Yep.
Okay.
That's for the margin of error.
Oh, okay. I'm like,
and then we plus and minus that from the...
Yes. Okay. Oh, that scared me for a second. Okay, yeah. You're right.
I realized I was like, that's that, yeah.
Wait. Okay. Okay. All right. So now with the margin of error, did you plug it into the equation?
Yeah, I'm doing that right now.
Perfect.
Okay, hold on one second. Okay, so what did you guys get for the lower one?
41.8.
Mm-hmm.
Perfect, that's what I got.
And then 51.6.
Yep.
Okay, cool.
Okay, and then so then for number 3, we do the same thing.
Just with the 99%.
With the 99%, yep. Do you guys want to, and then so down in the bottom last sentence, it gives the t-score of 2.9768.
Yep.
Okay, so do you have it, Allie?
Yeah, I've calculated out. It's 39.9
Uh-huh.
and 53.5.
Okay, that's what I got too.
Yeah.
And do you get that, Rebecca?
For number 3,
Uh-huh.
Okay.
yep.
Perfect. And then so then this part for number 4 for A and B is when you would use the software.
Yeah.
But like I mentioned, you still get the same answers as we just computed.
Okay.
So so if you just want to look at it when you have your computer.
Yeah.
And then how does the margin of error of the 95% confidence interval compare to the 99% interval? And so I got that the margin of error is smaller for the 95% than the 99.
Mm-hmm.
Yep.
Okay, good. Okay, and then so this one I just want to clarify because this was where I got a little nervous as if I was doing it right. So number 6, rather than estimating the age of his clients that buy investment properties, the realtor agent would like to test the claim that the age of his clients is different than the national average of age 47. Use the 0.05 as your level of significance. Follow the following sequence of steps. Fill in your answers at each step and show all your work. So state the null and alternative hypothesis.
So,
oh, sorry.
do you have a question about that?
Well, I did, but I figured it out, so I just didn't remember how to do it. So then I just did mu equals 47, or mu doesn't equal 47. Is that right?
Yeah.
Okay.
Yeah.
And so the reason it doesn't equal rather than is greater than or less than is it just says that it's different.
Okay. So the
He doesn't
difference.
say he thinks it's less than, or he doesn't say he thinks it's greater than. He just says different.
Perfect.
Right.
Okay. Okay. And then compare the test statistic. First compute it using the formula and showing your workflow, and then check it with the software. So, okay.
So that's so that one we just plug in basically what we've been given.
Yes. So then I show the formula T equals mean minus mu over S divided by square root of n.
Yeah, square root of the sample.
So
our mean is 46.73 minus the mu, which we just got as 47.
Okay.
and you put that over the sample, which is 8.83, or the deviation,
Mm-hmm.
Mhm.
and divide that by the square root of 15.
15. Okay.
So,
Okay. So for the sample, so same thing. It just kind of in the words it just says the age of his clients is different than the national average of age 47.
Mhm.
So it'll be probably pretty straightforward for that, right?
Yeah.
Okay. Okay, so the answer I got for that was negative 0.118.
Hold on 1 second.
Okay, sorry.
I
Yeah.
have to do it with my phone, so it makes everything super slow.
Yeah.
yeah, that's what I got, though.
Okay. Okay, good.
Mm-hmm.
Oops. Oops. Oops.
Okay. Wait, what did you say you got?
Negative 0.118.
Okay, perfect. That's exactly what I got.
Okay. And then state the degrees of freedom.
That's
So,
n minus 1,
yes. Okay.
14.
Yep, 14. Easy enough. Okay, and then sketch the t-distribution and shade the area which represents the p-value. So for this, on the textbook, they like showed the t. Okay, so sorry, I'm just looking at it.
You're good.
So when we would, so doing that, would we shade the middle? What do you shade on that?
Yeah. I would say you shade the middle because it's one where it's not left or right.
Okay.
Does that make sense? Because
Yes.
you said that there was a difference.
Okay. Because
So-
it's not less than, greater than. Oh, sorry.
This one where no, you're fine. Where you're sketching the t-distribution and shading the area which represents the p-value. So your p-value is actually going to be outside the middle. It's going to be the two ends.
Yeah, because
Oh,
it's
really?
neither
Oh,
left
yeah.
Oh.
It could be either.
Oh,
So
it
it would
could
be
be in the
both?
middle. Oh.
Okay. Well, I got half of it right.
Okay. Okay. Okay, so shade two. Sorry, I just like to write extra notes. Shade two ends.
Mm-hmm.
Okay. And then, so use your software to compute the p-value. So, you'll have to do that, but so I'll just double check my answer with Allie. The p-value I got was 0.9077.
Yeah.
Okay. Okay, and then, so state your decision. Do you reject the null hypothesis or fail to reject at the 0.05 level of significance?
So
So, oh, sorry. You go, Allie.
that would be
You
fail.
don't.
Yeah, you fail to reject it.
Okay.
And that's because it's greater than 0.05, right?
Yeah.
That's okay. That's what I thought too. Because okay. And then present your conclusion in an English sentence relating the result to the context of this program, of the problem. Sorry, not the program.
Love that question.
Allie, do you have a good? You usually have good sentences.
I don't. Whenever I try to do that, it always ends up sounding weird.
I know mine does too.
So the problem was, is the national average different than 47? And he had 15 of them, and I would say we don't know. We've calculated all the different things around it, but I don't know if the national average is different.
So on this one, it's your null hypothesis is that it equals 47, and then he's trying to figure out with his clients if his client's mean is different than 47. and you ended up from your p-value saying that you're failing to reject the null hypothesis. So you're failing to reject that his client's mean age is different than 47. So for that in an English sentence, you would pretty much just say there's insufficient evidence to conclude that the mean age of this realtor's customers who are buying second homes is different than the national average. That says natural average. That shouldn't say that. But yeah.
Okay, that's
So
yeah.
that
So that's
makes
easy.
that's easy enough.
Yeah.
Yeah.
I know we always tend to make things harder, I swear, than
I know, it's so true.
So
okay.
you just know that because you couldn't reject the null hypothesis, you have insufficient evidence to say that the sample mean is different from the population mean.
Okay. Easy enough. All right, you guys ready for the group meeting?
Yes.
Okay, so lesson 11 group meeting. Start.
Hold on one second, let me get there. So
start.
if we have anything for that we need to use the SPSS, can you guys just help me with like the numbers and then I'll help do the math with you?
Yeah.
Okay.
I complete.
Because I watched the video to see how you do it, and it's fairly simple compared to like the other ones that we've done in the past.
Right. And even, we can even all long compute it too, so that, because it helps me to know how to do it.
Yeah.
Right.
So.
Okay, sorry. I'm at my parents' house right now, and my internet's super slow.
Oh, no, you're fine.
So let me just pull it up. Okay. Okay, so I got pulled up now.
Okay. So number 3, in previous lessons, we have assumed the population standard deviation sigma was known. In this lesson, we are making a different assumption about it, about sigma. What has changed?
I put 3.
Okay,
Yeah.
that's what I said too.
Okay.
All right, the null hypothesis.
What's your guys' 3 on number 3? So did you put we assume sigma is the same as the mean?
No.
We assume sigma is unknown.
Okay, sorry. Your answers are just mixed up for mine apparently, so I was like...
Oh.
That's good to know, actually, because we've always just done that. Said,
Okay.
the number 3. So
That's good, though.
we better double check.
Just wanted to make sure.
Yeah. Okay, but that's right. It's unknown.
Yeah.
Okay.
Okay. So the null hypothesis is mu equals 8, and the alternative hypothesis is mu is greater than 8, and the population standard deviation sigma is not known. Becca collects the sample size of n equals 9 and computes the standard mean equals 11 and standard deviation equals 6. Use this information for questions 5 and 6. So is sigma known? No.
No.
And then what is the value of t? So then we can just go ahead and we can all do that one with you.
Yeah, that is easy.
Unless, Allie, you don't have to, but I just like to do it. I like to make things as hard as possible.
Yeah, I use SPS on the desktop. Like, I have to go in and find the other desktop, so I can just get to do it longhand.
Okay, good.
Yeah.
Hold on one second. Sorry, I gotta write all of it down. Okay.
Yeah.
Okay, and maybe I better double check with you guys. I'm doing the t equals mean minus u, or whatever mu. Is that the right one over standard deviation divided by the sample size?
That's what I'm doing too.
Yeah, square root the sample size. Don't forget that.
Oh, thank you. Over.
This one's pretty easy because it's just. So I got 1.5.
Yes.
Sorry. I'm almost there.
Round to 1 decimal point. Well, there's only 1 decimal point.
So 1.5?
Yep, 1.5. Okay.
All right. Use the following values, which were pulled from the data file body temp. Copy and paste them into the following software you are assigned to use.
So just tell me the mean, because I don't want to have to find the mean with all those numbers by hand.
Okay, yeah, no problem. If you get it faster than me, let me know.
Or maybe I'll try to beat you guys.
Maybe.
So I think it's possible.
Oh my word, SPS, stop freaking out. There we go.
Oh, whoops. Whoops. Ah. Okay.
Let's see. The meat. Okay, this is being ridiculous.
Oh my gosh, I'm almost done.
I'm doing it on my calculator just because.
Oh, darn it, I put 98. Okay, 98 point.
Oh, that's the worst.
Okay, so it's analyze, compare means, right?
You can do, for this one, just to find the mean, analyze descriptive statistics and explore. And that will just give you the mean and the standard deviation. When you actually go to do the t-test, that's when you'll do compare means.
Got it, thank you.
Mm-hmm.
Alright, I got it.
Oh, I got it too. 1, 2, 3, 4, 5, 6. What is it?
98.22.
Oh my gosh, I totally just did that by hand. Yay! Yay!
And
Okay, 98.22, that's what I got too.
So should we put a 0 at the end because it says round
Yeah.
3 decimal places?
Yeah, it actually gave me 98.2200. I just rounded.
Okay.
Oh, okay.
Okay, so mean equals 98.220.
Mm-hmm. And the standard deviation,
So
which
okay.
is the S, correct?
Which is
The
what?
S, did you say?
S for the next question, right?
Yes.
Okay, that's 0.92201.
Yeah, that's what I got too.
0.9. Hold on 1 second. My computer's freezing on me. Okay.
Yeah.
0.9221.
01.
Oh, 1.
92201.
But if it's to the 3 decimal places, then just 0.922.
Mm-hmm.
Okay, so you find that off of the program, right? SPSS?
Yeah, it says STD deviation, so.
Okay.
Okay, and then what is the t-score?
Click here, analyze, compare means, one sample t-test. Okay.
So what is the t-score?
It just says, it's just T, right? So that's 476.407.
And you got to make sure when you do the compare means for this that you put the test value in.
Oh, yeah. I remember that.
So I'm guessing from the answer you got, you probably forgot to put that in.
So isn't that where you put 98.6 in?
Yep.
Okay.
Wait, what?
Yeah, I'm confused too.
Okay.
So
give me 1 second and I'll screen share this with you guys and show you how to do it.
isn't it when it pops up, you put that in the little box before
can you guys see that?
Yeah.
So you do it just like you would normally do, compare means, one sample t-test, and then this will be over here. So you move this, and then in this little test value box, that's where you put your null hypothesis or your population mean. Okay. And if you don't do that, you're going to get the wrong T. So make sure you put that in there, and it'll be the right one.
So in this case, it's 98.6.
Yep, just because it gives you that right in the problem.
Mm-hmm.
Okay, and that's where I was confused too, because I forgot that it was in the problem.
Now I can't figure out how to stop my screen sharing.
Oh.
I think I can stop it.
Okay.
You figured it out. Yeah.
That was weird. Usually it gives me a stop button, and that time it didn't. I was like,
Oh.
Anyways.
It's negative 1.843.
Negative
1.843?
Negative 1.843, yeah.
Okay.
That's quite a different answer.
Yeah. I think one of the ways that I always know if I did something wrong is if it's like a really big number, if it's something like this,
Mm-hmm.
and also with like the p-value.
Yeah. How do I can't remember how to do the p-value. I did it earlier today.
I know, same.
Can't you just do it by hand?
I think so, but okay.
So for p-values and SPSS, it gives you it to you in that exact same table. It gives you the t-score. So the box labeled SIG two-tailed, that's your p-value for a two-tailed test.
Right. Okay.
And then, but if it's not a two-tailed, don't you divide it by 2?
Yep.
Okay.
Oh, yeah. Okay.
Okay. So it's 0.081. And this one is not a two-tailed.
Okay.
So you gotta divide that by 2.
So you have to divide that by 2?
Okay.
1 divided by 2. So that's 0.0405.
That's what I got too.
So wouldn't it be 4, 1?
Yes.
Yeah. 0.041. Yeah.
Mm-hmm.
Okay. What is the correct decision based on the evidence?
You would fail to reject because don't you go off of the p-value?
Yeah, so the p-value is 0.041, and the level of significance is 0.05. So I would say reject it.
That's
Right.
what I would said too.
So
yeah.
you would reject the null hypothesis?
That's what I would say, because it has to be bigger than 0.05
to fail.
to fail.
Right.
No, I think in order for the null hypothesis to not fail is if the p-value is bigger than it. But since the p-value is smaller than 0.05, right, then it would fail to reject the null. No, it would be reject the null. Sorry, I don't know what. In my mind, I knew what I was saying, but anyways, okay. Sorry.
No, you're totally fine. I know it's good to talk through them because I had to think about it too, and then I had to read my definitions for the two.
Right.
Okay, so use the following values which were pulled from the data file Baby Boom. These values are the wait time in minutes between births at a hospital. Copy and paste them into your software you are assigned to use. The hospital claims that the average time between births is 40 minutes and it plans its resource allocation based on this claim. You want to test the claim, you select mu equals 40.
Okay.
So your first alternative hypothesis is mu is not equal to 40, and you use a level significance of 0.01. What is the p-value? Round to the 3 decimal places.
Okay. So that's just a quick calculating here. One simple plan.
Because you're able to do this because you have SPSS.
Yeah, just really quick.
Oops.
Okay.
So I gotta change that to 40. Okay. So I got 0.995, but we have to divide that by 2.
Yeah. Okay. So, sorry, I'm almost there too.
And if you look on this one, your alternative hypothesis is that it doesn't equal 40. So is that a one-tailed or a two-tailed test?
That's a one-tailed.
Oh, that's a two-tailed test.
Is it a two-tailed?
Yeah.
If it doesn't equal, it could be either or.
Okay.
We're not specifying, so it's two-tailed.
So in this case, you don't divide the p-value.
Yeah, in this case you don't divide.
Oh, okay. Yeah, because it is a 1. No, it's 2. Okay, I got it. Sorry. So then it was 0.995.
Okay. So then this
Fail to
one,
reject and null.
It's, fail to reject. Okay.
okay.
13, you decide to try another alternative. This time you use greater than 40, or less, mu is less than 40, and you keep the same level of significance. So now you divide it by 2.
Okay.
So
So it would decrease, right?
yeah.
Because you divide the answer by 2, you get 0.497.
So what decision do you make? And we,
Fail to reject.
yep.
Okay, so 15, compare the width of the confidence interval for question 11 to the confidence interval for question 13. Which one is wider?
So is it 13?
I would say it would be 11 because I mean, I don't know if this is right or not, but because the p-value is a lot bigger than the one, well, not a lot bigger, but bigger than the one in 13, then that would make it wider. Is that
You're right.
Yeah,
is that true?
that's what I'm going with.
Okay, so for this one's kind of confusing, but between the questions, you're changing your alternative hypothesis, but you're not changing any of the data at all.
Mm-hmm.
So in this
Okay.
case, your confidence interval would still be the same.
Oh.
Oh.
You're not changing any of the data, you're just changing your hypothesis and what you're trying to find out about the data.
Oh, okay, so you're not comparing the p-values.
Yeah. Does that make sense why it wouldn't change though?
Yeah. Uh-huh. Yeah, we should have you on the call every time.
I know, seriously.
Like so
And
helpful.
we're taking tests.
I read that you do you tutor Tuesdays and Thursdays at 5. Is that correct?
Yeah.
Okay. You may be seeing me every week.
I was going to say, maybe we should do tutoring sessions at
I
5 and then
know,
our
right?
group meeting at 5:30.
Yeah, because I second guess myself a lot, and so it's good to have somebody, or like something like this where I don't completely understand it, and then I end up getting it wrong and I don't know why.
Yeah, I
Yeah.
hear you.
Okay. Well, thank you.
Wait.
No problem.
Let's submit that.
Hey. Woohoo!
Awesome.
Thanks, Kirsty.
Yeah. You're welcome. Well, great job, guys. You guys seem like you're understanding things pretty well, which is good.
We're trying.
Yeah.
Good bits were a little iffy, but you guys are doing good.
Normally we're more on top of things. I don't know.
I know.
Well, normally I'm more on top of things.
That is true. I'm never on top of things, but
No.
but today,
No.
no,
Well, thank
exactly.
you guys for letting me join. I appreciate it.
Yeah.
Thank you. Thanks for your
And
help.
good luck.
Yeah,
Thank
thanks.
you.
Okay, so I'll post this onto the discussion board.
Okay.
All right.
Okay.
Okay. Bye guys.
Thanks. Bye, guys.
Tuesday at 6 work?
Tuesday at 6?
Yeah.
Yes.
Okay. Thanks guys for being so prepared. I'm sorry.
Oh no, thank you. You're awesome.
Okay.
Every time.
Okay. See you guys next week. Bye.
Bye. Bye.